Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. In this video, I'm going to show you how to create a remote access VPN using Wireguard and Fedora Linux. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone who's watching who hasn't subscribed to click that subscribe button and ring the bell when you do. Also, if you enjoy the video or found it useful, make sure you click like and feel free to share it with others. Before we dive into the technical details, I want to explain a bit about this project. First, what is a remote access VPN? That has several different definitions, but for this project, that is going to be a single server that is publicly available on the internet and one or more clients that will establish a VPN tunnel to this server for the sole purpose of sending all of their traffic to this VPN server before going out to the greater internet. So in order to be able to do this, you need to have a publicly facing server. And one of the easiest ways to make that happen is by using a VPS service, which is what I'm using for this particular project. I'm using the Vultr VPS service, VULTR. There are many others out there, Linode, DigitalOcean, you name it. If you can have a publicly facing server that has obviously a publicly routable IP address, then you have what you need to be able to create this remote access VPN as I'm doing in this project. So now let's dive into the how-to. So here I have my Fedora 38 workstation and I have two terminal windows open. I know I could do this just as tabs, but I like having the two different windows here. And I'm going to first sudo into root for both of these because most of the commands we're going to need to do all the configurations are going to require root privileges, and it's just easier to be root rather than prepending sudo to all of the commands. And we'll do this on the second terminal window. All right, next we're going to SSH into our Wireguard server. So this is the publicly available server that is running on Vultr. And VPS, by the way, stands for Virtual Private Server, in case you were wondering. I know I mentioned that in the introduction and didn't define what that is. So let me clear my screen, and we have root at Wireguard server. That's what we want, and root at Wireguard client. So the first step is going to be configuring Wireguard tools or rather installing Wireguard tools for both the client and the server. So we're going to use DNF install Wireguard tools -y. We'll do the same on the server. Oftentimes I don't do -y because I want to see exactly what's going to be installed along with the package that I want, such as dependencies, but I've tested this a couple of times, so I already know what's coming, so we'll go ahead and do the -y. Next, we're going to generate the key pairs for both the client and the server. I've already cleared the screen, so that way the results of DNF are gone. So to create our key pairs, we're going to use the wg genkey command. We're going to pipe that to T, not tel, but T, and output it to a file called private, if I can spell that right. It's tough to speak and type at the same time. Private.key. Since we use the T command, there's still going to be standard output. So we're going to pipe that to wg pubkey, and then output that to a file called public.key. The reason why I'm doing it this way is in order to have a public key, you must have a private key. And so doing this particular piping will allow us to generate both and give us two files, each with the particular key that we need with the pair. Once we've generated the key pair and we've included it in our configuration, there's really no need to keep these files around. But if you do, I recommend you set their permissions to something like 600 or 400 and make them only readable by root, especially the private key, because you don't want that to be shared when you don't intend for it to be shared. So now we're going to do the same thing on the server. So wg genkey, pipe that to T, and private.key rather, pipe that to wg pubkey, and output to public.key. And there are two files. The next step is going to be actually configuring the Wireguard network interface. And so we're going to do that on the client first. So There are a couple ways of doing this. I'm going to use the nmcli commands because Network Manager comes with Fedora server and Fedora workstation for that matter. You can use the WG quick tool and its configuration file to do this. Both are valid. I'm just choosing to use nmcli. So I will use nmcli con add type wireguard. You can also use tab completion with a good bit of this. We'll do con name wg0, if name or interface name wg0. These don't have to match. I tend to make them match just because that's how I like it, but feel free to do what you wish with that. And we're going to set auto connect for this interface to no. And the reason for that is we don't want this on all the time. We only want to use the VPN connection on our client when we are specifically wanting to tunnel all of our traffic to the VPN server, such as if you're on a network that is not well trusted, you have this on, your traffic is encrypted to your VPN server and then goes out to the rest of the internet. But if you're on a trusted network, there's really no need to send that traffic to the VPN server because you're already trusting that nothing's on that network necessarily that will sniff that traffic. Next, we're going to configure the IP information. So nmcli con mod now wg0 IPv4 method is going to be manual. You cannot use DHCP with this. And IPv4 addresses, we're going to use 10.0.100.2/30. Now, most of the actual routing is done with crypto key routing, which you can look up documentation about that with WireGuard. It's basically how WireGuard decides where to send traffic based off of the public and private key pairs. However, if you're in a situation where you might have multiple clients and you want to route traffic between them, then you're going to want valid IPv4 addresses. And really I would say that's a good practice to do for any network interface that's going to be receiving internet protocol traffic. You want to have just valid addresses. Since this is effectively going to be a point-to-point between this client and this server, I'm using the /30 subnet. But if you wanted to have potentially other clients on the same network, you would use the appropriate subnet mask for that. You do not need to configure a default gateway for this interface because it's actually going to be using the default gateway of your just normal network that you have configured on your client. The only difference is once the WireGuard interface is turned on, the routing table will be altered to where your system knows both to send traffic through your actual default gateway to the internet and to have that traffic go through the WireGuard tunnel. Next, we need to configure the actual WireGuard bits of the WireGuard interface. So we'll use nmcli con mod wg0. Or actually, before we do this, we need to copy our private key. Got a little ahead of myself there. So cat private.key. I suppose I could have used a subshell in the command to get the private key, but we'll copy and paste. So nmcli con mod wg0 WireGuard dot private key, and you can use tab completion. I'll usually put this in single quotes just in case the private key happens to come up with a character that Bash is not going to handle well. And you might think that is it. However, we also need to configure our peer. So WireGuard needs to know where to send traffic once the interface is up and running. Unfortunately, as of right now, which is July 2023, nmcli does not support configuring the particular properties to be able to make this happen. So we need to do a manual configuration of the network file, which is not difficult to do. We'll just need to use a text editor to do that, and I'm going to use good old VI. To Etsy Network Manager, System Connections, and the name of our connection, WG0. We're going to add a section. We're going to call it WireGuard-peer dot. Now, what goes beside the dot is going to be the public key of whatever your peer is. So that's going to be our server here. And I'm probably going to have to redo my SSH connection. Yes. By default, the installation of Fedora server on Vultr will time you out after a while, which is not a bad thing at all. So we'll cat the public key. We're going to copy and paste this. And now we need to set some parameters. Before I do want to make a note that, syntax and spelling count for everything, but especially WireGuard. When I was doing some of my tests, I had some strange issue where everything looked like it was up, but traffic and such wasn't being passed properly. And it took a good bit of troubleshooting to realize that I simply had a syntax error. I had wireguard.peer instead of -peer. So as you're doing this, make sure that you're very careful with your syntax, and that way you don't waste time troubleshooting something that is simply a typo. So the first setting is going to be endpoint. If I spell that correctly. Speak of the devil, right? So the endpoint is going to be your peer. So that way WireGuard knows where to send the traffic. You can use an IP address or fully qualified domain name. I'm going to use IP address. So that will be 144.202.16.232. Notice that is a publicly routable IP address because since this is on the internet, you need to have that particular type of address, and you get that usually with your VPS server. And we're going to be sending traffic to port 51820. In theory, you could probably use any port for WireGuard, but everything that I've seen with it always uses 51820, so I'm just keeping with the convention there. The next setting we're going to need to configure is allowed IPs. And this is something that I think people tend to make a mistake with. And if you are troubleshooting a WireGuard connection, make sure your allowed IPs are correct kind of as an initial troubleshooting step, because if you get this wrong, traffic is not going to flow. The thing to remember about allowed IPs is for traffic that is coming into your interface. So this is from the outside world, from your WireGuard server, sending traffic to you. The destination of that traffic, the destination address, needs to match the allowed IPs. And then for the other direction, if you are sending traffic out to your WireGuard server, the source address needs to match what's in your allowed IPs. So since we don't always know what the source address is going to be of traffic that's coming back, nor do we know the destination address always of traffic that we are sending, we need to set this to 0.0.0.0 and give it a subnet of 0. This basically says allow all IP addresses. So to think about this, let's say we go to google.com, that will be a particular IP address. We don't always know what it is. So having this set to the all zeros will allow any traffic to leave that has a destination of whatever. And then when that traffic comes back from Google, the source of that traffic can be whatever address. Next, we're going to configure the persistent keep alive. And what this is going to do is send a little packet to your server every however many seconds. For this, we're going to use 20. And the reason you're going to want this is because if you're in a residential internet connection or any internet connection that has DHCP handing out an IP address, or you're behind NAT, or you're behind a couple of layers of NAT, and you'll have the one IP address and you can have multiple ports being used for your traffic. This persistent keep alive helps the server know where to send traffic back to, since it's not always going to be a fixed endpoint. Having this little keep alive in case you have traffic going and that IP address changes, the keep alive will help the server know where to send that traffic back to. So we'll press escape to go back to command mode in VI, and I'll use :X to both close and write the file. Next, we need to load this configuration we need to load the configuration for Network Manager. So we'll do nmcli con load and then our file name. So etc Network Manager, System Connections, WG0nm connection. And that is it for the client configuration for WireGuard. We can do wg show wg0. Actually, yeah, it's not going to show anything yet. We haven't actually turned on the interface, but once we do, we'll see some of the connection. But as far as configuration, the client is now done. So now we're going to turn to the server. The server configuration is going to be very similar to the client configuration. First, let me re-SSH into our server. We'll clear our screen, and we'll start by creating the network interface. So nmcli con add, type will be WireGuard, con name, we're also going to call this WG0, and if name will be WG0. I'm going to set auto connect to no. We'll turn this back to yes at the end. The reason why I'm doing this is I have seen problems happen before. If the network connection somehow comes up and it's not fully configured, it shouldn't be an issue, but since I was bitten once by it, I just do the auto connect no for right now. But we'll set that to yes because we obviously want our server being able to listen at all times. I'm going to cat the private key. So we're going to need that in a couple of minutes. We'll set the IP configuration. So nmcli conmod IPv4 method. Oops. nmcli conmod wg0 IPv4 method will be manual. IPv4 addresses, if I can spell, this will be 10.0.100.1/30. And for the WireGuard bits, so nmcli conmod wireguard.private key. We'll copy our private key here. And we're also going to specify the listening port. So nmcli conmod wg0 wireguard listen-port, and we're going to set that to 51820. We didn't do this on the client because the client is going to pick a port at the time of setting up its connection. The server, however, needs to have a consistent port that the client always knows to reach out to. And just as the client, we need to manually configure the network configuration file to set up the peer information. Get some syntax highlighting with the version of VI that's on the Vultr Fedora install. It probably has Vim instead of VI, and that's fine. So we use WireGuard-peer again, dot, and we need the public key of our WireGuard client. Cat that there. Copy paste. And the only configuration we need to add now are allowed IPs. Endpoint does not need to be specified because the server is going to learn that once the client connects, and persistent keep alive doesn't really make much sense, simply because the endpoint is always just going to be learned from the client. You're not going to have traffic initiated from the server to the client. It's always going to be client to server, and then whatever response goes back to the client, but the server is not going to be initiating the very first traffic. For allowed IPs, we need to set the client's IP for this. So 10.0.100.2. We'll press the escape key to go back to command mode for VI and press :X and then enter to save and write the file. And then we will reload the configuration file. nmcli con load etc network manager system connections wg0. So we're not quite done with the server yet. We need to allow traffic to come to the port that WireGuard will be listening on. So we're going to use firewall CMD for that. You can also use NF tables or IP tables or whatever you wish. Also, I'm just doing this to the default zone. If you wanted, you could configure this to have the WireGuard interface in a particular zone and then do all this for that particular zone or profile. We're just using the defaults here. Add port equals 51820 UDP, which is important for WireGuard. It is operating on UDP instead of TCP. Permanent. Oh, UDP, not UD or UPD. There we go. It's the beauty of doing it live, right? We also need to set up IP masquerading or port address translation. This is because we're going to have kind of multiple entities using the one public IP address for our WireGuard server. And so this is going to allow the connection to be tracked. So when traffic comes back to the WireGuard server to then go back to the client, the networking system on Linux knows where to send that traffic. Next, we'll do firewall -cmd -reload. Anyone that has worked with firewall CMD, you've probably forgotten to do reload after doing permanent and your configurations aren't there, but this will make sure that they are there and they are valid. And we're going to now set the interface to where it will come up automatically. NMCLI conmod WG0 auto connect. Yes. And now we're ready to go. Let's bring up the interface. So NMCLI con up WG0. No error messages. That's a good sign. Let's clear our screen and we'll do WG show WG0. And we see our interface and its public key and that it's listening on this particular port. And it is aware of one peer that will have traffic that is sourced from 10.0.100.2. And again, the way that allowed IPs works, the traffic that is received by the server, it's going to be checking the source address against allowed IPs. And then the traffic that it will be sending back to the client, it's going to be checking the destination address. Because remember, since we're using the masquerading, that NAT translation is going to make sure that the destination IP address is as we intend it to be. I'm actually going to exit the server now, and let's go back to the client. Let's clear the screen, and we're going to use curl, and we're going to, if I can spell, https ifconfig.io. And this website tells you what your publicly available IP address is. So traffic that's leaving my network is showing up as 172.56.67.188. So now let's turn on the WireGuard interface. So NMCLI con up WG0. No error messages. Let's take a look at the statistics and we see the information that we would expect. The listening port is just chosen at the time that we bring up the interface, and this FW mark, that is used by the networking system on the client to know when to send traffic over the tunnel and when not to send traffic over the tunnel. I'm not going to go into the details of the routing with that, but just understand that's what that's used for. And we see our peer, the endpoint address is our publicly available address, and it's sending traffic to 51820. And we see that the latest handshake was 3 seconds ago. Obviously, it's been a little bit longer than that now, but this is showing that the connection does appear to be up. So let's curl. Let me clear. No, I won't clear the screen. Let's curl again. HTTPS ifconfig.io. And now we see a different IP address appear, and this should match the IP address that is of our server. Obviously it does. You can see it there on the screen, but IP adder show, and we see the actual network interface for our server, and that matches. So we now have a successful VPN connection, and we are sending traffic to our WireGuard server. It is over an encrypted tunnel, and then it goes out to the internet. But we always want to make sure that our connection or our configuration is going to persist with something like this. So let's reboot both the server and the client, and let's see if this persists after the reboot. All right, so both our client and server are back up. So moment of truth, let's launch our browser on the client here. And as you can see, this is the first time I've launched it. And we can go to ifconfig.io in the browser as well. So https ifconfig.io. You can also use, I think, whatsmyip.org. I've used that in the past as well. And I'll zoom in here to make it a little bit easier to see. And we see that the address is showing the address that I would expect from my internet service provider. So we're going to turn on the VPN. We can do that from the command line, or you can also do it from the menu here on GNOME. We will press VPN. And I'm actually going to do another tab. When I was doing some testing with this, sometimes just refreshing that page it's like it froze. Not quite sure why. But we'll do ifconfig.io. And now we see that our IP address is 144.202.16.232, which is what we expect from our VPS server. So everything has survived a reboot. We are all happy. And then to turn off the VPN connection, we can simply go back to the GUI. It will tell you connection failed. That's not an error. It's just the fact that we've turned off that network connection. Now, one thing I'm not going over in this video is server hardening. Obviously, if you have something that is on the public internet, you're going to want to take some measures to make sure that your server is more difficult to be broken into. I'm not going to say 100% protected because there's always going to be some vulnerability somewhere that someone hasn't found yet, but you need to take measures such as make sure that you have SSH key authentication, make sure you disable any services that don't need to be on, such as Cockpit is usually something that's on by default. You probably want to turn that off. And there are some other things that you can do for server hardening. You can look at all sorts of articles about that, but I do want to encourage you, if you are choosing to follow this, to set up your own remote access VPN using Wireguard. Don't forget to do some server hardening for your VPN endpoint on your publicly available server. So to review, the basic steps for this are installing Wireguard tools, generating key pairs on both the client and the server. You'll need to set your network interface, and you'll either do that using some of the networking tools such as NMCLI and configuring a network file, or if you're doing the WG quick method, there's a configuration file that you'll set up to establish what your network is and what the peers are. On the server side, you'll also need to configure your firewall, and then you'll want to make sure that your configurations persist if there's a reboot of your server. So it might seem complicated, but it really, when you think it through, it is not difficult to create your own remote access VPN using a VPS server or any server that's on the public internet that you control, which is kind of a nice thing if you enjoy running your own infrastructure. So I hope you enjoyed this video and found it useful. If you did, make sure you click like and feel free to share it with others. I want to thank returning subscribers again for watching another video, and to invite you, if you're watching and you haven't subscribed, to click that subscribe button and ring the bell so you can be aware of when new content comes available. Thanks again for watching, and as always, I'll see you the next time.